Hi guys, and in this video we're going to look at the Unit 3 Independent Task 3. So in this booklet you had the 5 questions: binomial expansion, constant functions, trigonometry identities, arc, length and area of a sector, and also modulus functions. So you should have already had a go at the 5 questions and then got to a level of support. So just a reminder again, if you're getting to level 1 or level 2, so you just look in your books, or maybe you need to watch a video, then that's quite a low level of support that you needed. So maybe just a quick little recap, a couple of exam questions, and you'll be ready to go. If you get into 3 or 4 where you're speaking to a friend or a teacher, you must be highlighting that as a big topic that needs to be looked over. Okay, you need a lot of work on it if you get into this stage down here. Okay, so for the first question, we have a binomial expansion. Okay, so it tells me to expand for part A, 1 plus 6x, 1 plus 6x to the third in ascending powers of x up to including to x squared. So I want up to x squared here. So I'm going to use my formula in my booklet. So first one's 1 plus n, which would be a third, times 6x, plus, and the next one's going to be a third, so n, then in brackets, n minus 1, so a third minus 1, all over, in this case, 2 factorial, and I'm going to have 6x and then all squared. I'm going to times that by. Okay, now I don't need to go any further because this last term is going to give me x squared. So if I simplify all this out, I get 1 plus 2x. Now what I'm going to do is I'm going to plug everything in here into my calculator. So I'm going to do this fraction, and I'm going to times it by 36 because that's going to be 6 squared, and I get minus 4x squared. So there's my expansion done for that first part. Now for part 2, now normally we would do this naturally, but they split into a second section. It says states the range of values of which the expansion is valid. So normally it should be the mod of x being less than 1. So, but my x is 6x. So I've got the mod of 6x being less than 1. So I can rearrange that by dividing by 6. Should be a sixth. Now part B is where we get to use our expansion a little bit. Use your expansion in part A to find the approximate for the value of one root of the equation. So here is my thing I'm going to use here. So you see I've expanded this bracket here and I've got times by 2. So if I'm thinking what I've got there, I've got 2 times my expansion, which is 1 plus 2x minus 4x squared. And obviously that's I'm approximating it, equals 2x squared minus 15x. So I've got a quadratic form here. So let me expand this left-hand side. So 2 plus 4x minus 8x squared is 2x squared minus 15x. I'm taking everything onto one side, which in my case will be taking it to the right. So I've got 10x squared, and take it for minus 19x, and then minus 2. And I'm going to factorize and solve for x. Okay, so I've got 0. If I think about factorizing into a double bracket, I've got 10x plus 1, and I've got x minus 2. So that means x would have to equal minus a tenth, or x equals 2. Now, I need to pick which value, because if you notice, it just says for one root of the equation. Okay. Now, I'm going to go with what it's valid for. Okay. Mod of x has to be less than a sixth. Now, the mod of 2 is not less than a sixth, whereas the mod of minus 10 is. So it has to be the minus a tenth. So therefore, x equals minus a tenth. Okay, because this 2 does not fit in what is my expansion is valid for, so I can't use it. Okay, so for question 2, okay, we've got composite functions. So I've got 2 functions here, f and g. I've got f of x has a domain of 0 to infinity, and g has 0 to pi by 4, respectively, and defined below. So f of x is ln x and g of x is tan x. So what I'm going to do first, before I can do anything, is I'm going to write down their domains, okay, and ranges. So the domain of f is 0 to infinity. Okay, now if I think about what this function is, okay, the range of f, okay, if I plug in 0, I get really big negative numbers. As I plug in really, really big numbers, I get positive infinity, okay? So that's my range for f. Okay, let's look at the same thing for g. So domain of g is 0 and then pi by 4. And it's a square bracket. Now if I take those two and I plug them into tan, so tan, range of g. 0 gives me 0, and pi by 4 gives me 1. Okay, so for part 1, I'm going to use these. That's why I wanted to do them all first. Write down the domain of f of g. Okay, so to do my domain, I mostly look at this last term here, so g. My domain of g is 0 to pi by 4. And all I'm going to do is I'm going to check that the range of g then fits into the domain of f, and it does. So that means I can just use the domain of g in this case, just pi by 4. I don't need to restrict it in any way. Okay, then part 2, so that was nice and straightforward, is the range. So the range is a little bit harder with this one, okay? If I look for the range, if I'm going to consider the range of g, okay, so what's going to happen is I'm going to put something into g first. It's going to spit me a number out. I'm going to take that number and put it to f, and then it's going to spit it out, okay? So if I look for the range of g in this case, it's going to be 0 to 1, okay? Which means this is my new range of f, or domain of f. Okay, so that's what I'm allowed to put into f, okay, which is different from 0 to infinity. So I've got to think about it. If I put 0 to 1 into here, what kind of answers do I get out? Okay, so my new range of f of g, if I put 0 into f, okay, I get really big negative numbers. Okay, if I put 1 into f, I get 0. So it's restricted it very slightly compared to the range of f at the end. Okay, so it's not always going to be the same here. Right, B, show that f of g is equal to solve the equation of f of g of x equals minus 0.4, given your answer correct 2 decimal places. So I'm going to dive into this. So f of g of x is what I'm going to solve for first, okay? That is going to have to be ln of tan of x, okay, which isn't the nicest thing ever, but he told me that equals minus 0.4, and I'm going to solve this. So the first thing, let's get rid of the log. So tan x would have to be e to the minus 0.4. So that means x must be inverse tan of that. So tan to the minus 1 of e to the minus 0.4. Now, I should be in radians because my domains are in radians. Okay, so make sure you are. Sorry, radians, not the radians. Okay, and it gives me 0.59 out as my answer. Okay, make sure it's in radians because look, my domain's in radians, so it means I'm only allowed to put radians into it. Okay? Like part 2 says, given a reason, write down a value for k so that f of g of x has no solutions. Okay? So for that, what I'm going to do is I'm going to look at the range. The range of f of g is minus infinity to 0. Okay? So I can only get out numbers in this range, which means I can pick any value for k that isn't in this range. Okay, so I need to state that, don't I? So let me, it said give a reason, okay? So k can be anything outside this range. Okay, if we look at the previous question, it was minus 0.4, which is in this range, so I could use it. Okay, so I'm just going to pick any number. You could have picked any number. I've gone for 4. Okay, you could pick 8, 12, something, as long as it's bigger than 0 and a positive number. Right, topic 3, we've got identities. Okay, so you would have done these loads and loads in Unit 1, okay, but it's just we got new identities to use. Okay, so I've got, again, 0 to 360, so make sure we're back in degrees now. I've got 8 tan squared minus 5 sec squared equals 7 plus sec theta. Okay, now it's important here. We do have an identity that links tan squared and sec squared, so I've got to get rid of one of those. I can't get rid of the sec, which means I have to get rid of tan. Okay, now we know that sec squared of theta is 1 plus tan squared of theta. So if I rearrange that, tan squared of theta would be sec squared theta minus 1. So I'm going to sub that in now. So I've got 8 of that. So 8 sec squared minus 5 sec squared is 7 plus 4 sec theta. Okay, now it's the usual things. We're going to expand, make a quadratic and solve it. So let me expand this single bracket first. Okay, now I'm going to start to collect things. Let's take everything over to the left-hand side. So I get 3 sec squared theta minus 4 sec theta, and I'm going to get minus 15. Again, we're going to go to our normal things. Let's factorize. Okay, if you are using your calculator, you need to make sure you put the brackets in afterwards. Okay, work backwards. So I get sec minus 3, or I get 3 sec plus 5. Okay, so that means sec theta would equal minus 3, and sec theta would equal minus 5 over 3. Okay, now we don't have a button for sec, so we need to use our rules. Okay, sec is 1 over cos. So cos of theta would be the reciprocal, so minus a third in this case, or cos here would be minus, sorry, it should be positive 3, shouldn't it? Okay, it should be minus 3 over 5. Okay, now I'm going to do what we always did last year. I'm going to do inverse cos, which gives me 70.5 degrees. I need to find the other one. So you can think about your graph. Cos graph looks like this. If I could draw a bit better, let's put my x-axis there. Just ignore this one. Okay, there's 70. So I go straight across. I'm looking for this value, okay, which is going to be 289.5. Okay, and I do my theta by here. That gives me 126.9. And then if I find my other one, so that would be down here. If I find my other one, so I go backwards from 360, I'm going to get 233.1. And there are my 4. Now, if you want to put them in one line afterwards, that's completely fine. But there are my 4, nice and clear for the reader. Right. Arc length and section. This is quite a difficult question, so we do need to break it down a little bit. Okay. I've got the diagram shows a sketch of a circle with a radius of r and 3 points A, B, C on the circle. The line AC is the diameter, and A to O to B, so this angle here, is 2.15 radians. Given that the area of BOC, so this red area, is 26 centimeters squared less than the other area, so this area here in orange, find the value of R. Okay, so what I'm going to do first, I'm going to find 2 expressions. Let's think about the area of AOB, so the orange one. Okay, area of a sector is a half, I think about area, half R squared theta. So I've got a half R squared times by 2.15. Okay, I'm going to leave it like that. Okay, area of the other triangle, okay, so the other sector, BOC, would be a half R squared still, so it's part of the other one, times by, now this angle on this side, half a term would be pi. I've already got 2.15, so it's going to be pi minus 2.15. Now I can use what they told me. BOC is 26 centimeters less than A, so the other one. So I can say that a half R squared and then pi minus 2.15, okay, is equal to the other one, so a half R squared times 2.15, okay, minus 26. Now I'm going to spend time now and rearrange and solve this. So I'm going to add 26 over to the left, and I'm going to move this term on the left over to the right. So I've got 26 over here, and over here I've got a half R squared times 2.15, take away a half R squared, and then pi minus 2.15. Now, you'll notice I'm leaving it on top of this. If you times out, that's fine, but you'll notice you'll just have loads of recurring decimals all over the place, or just decimals in general, and it's just a little bit more accurate here to keep going like this. So I'm going to times by 2, so that gives me 52 on this side. I'm going to factorize an R squared out. So I've got R squared is 2.15 minus, and then pi minus 2.15. Okay, and I'm going to divide by that bracket to find myself what R squared is. So R squared comes out as 44.88, which means R would have to be 6.7 centimeters. Again, if you have not left it in terms of pi all the way through like I did, you just got to be careful about your rounding and make sure you're not rounding too early. So for the final question, we have modulus function. Okay, we got a bit of sketching, a bit of describing it. Okay, so the first thing I'm going to do is I'm going to sketch my axes. Okay, so let me draw a set of axes really quickly. So I'm going to have my X and my Y. Did I not pick? There we go. Okay, and I'm going to plot my two graphs. Okay, so I need to sketch this graph here, which is y equals the mod of 12 minus 5x. Okay, and then I also need to plot y equals minus 2x plus 3. Now I can probably do the second one quite easy. Okay, it's going to cross at 3, so say 3 is about here. Okay, it's going to have a negative gradient, and let's figure out when it's going to hit the x-axis. So when y is 0, x would equal 1.5, so 3/2, or 1.5. Okay, so let's say that's about here. Okay, so I'm going to have a fairly straight line between those two things. Okay, so let me draw a nice straight line between those now. So I've got 0.1 and I've got 0.2, so a nice straight line. Okay, that would be my y equals minus 2x plus 3. I'll mark out this point as well, so we know where that is. Okay, the harder one for me to plot is this one. Okay, so let's imagine instead I was looking at this. Okay, it's going to cross at 12, so 12 will be all the way up here somewhere. Okay, that's my first bit. Okay, the second bit is, let's do when y is 0. Let's see what happens. Okay, let's solve for x. X would be 12 over 5. Okay, so we got 12. So that's where it's going to hit the x-axis. So 12 over 5. Okay, which is obviously 2.4. Okay, so that's 2.4, which is obviously further across. So if that's 1.5, 2.4 is going to be roughly about here. Okay, so that's going to be 12 over 5. Now, normally the line would keep coming down past that. But however, we know when it hits when I do the modulus, okay, as soon as it gets down to negative values of y, it's going to flip it. So it's going to repeat it up. Okay, so let me get now what this one's going to look like. I've got a point there, and I've got, move up a bit. So it's going to hit my points, and then it's going to bounce up in the other direction with the same kind of gradient, okay? Roughly like this, okay? Mine's not very exact, but we can get a grasp of the kind of shape that it has. Okay, so I've got my two curves, my two lines there, and that's it, okay? Then it states with a reason whether there are any solutions to the equation of this. So just making these two things equal to each other. Now, if I look at the graphs, they don't cross, do they? Okay, now because they don't intersect, it means that they have no solutions. So I'm going to state that, okay? It's going to say it has no solutions as the graphs do not intersect. Okay, and it never will, because I haven't drawn it very well, but this green line should be a lot steeper because it's got a gradient of -5, which has only got a gradient of 2. So this pink line will kind of like flatten out, whereas this green line should be a bit steeper. So they're not going to come together at all. Okay, they would have come together if I carried them on down below the x-axis. Okay, but obviously with the modulus, it makes it flip back up. Okay, so that's it for this video. Make sure you've marked that. Again, make sure that you've made a note of the level of support that you've got to. But apart from that, okay, I'll see you in the Unit 4 video. Okay, thank you guys.